Hey guys, welcome to Corona Times. We're going to use some logical rules today to do what's called deductions. Deductions are things that must be true if the premises are true. Remember the definition of validity. If the premises are true, then the deduction must be true. The conclusion is the deduction. If the premise is true, the conclusion must be true. We'll have rules. We have 5 of them. I'm going to teach you some of those rules today and how simple they really are. Let's start with the basic rule, the simplest rule we know, the AND rule. Here we have an AND, P and Q. These rules are called elimination rules. What they do is they eliminate connectives. We have 5 connectives, only 4 of which actually connect anything. Then there's the not. Don't worry about that. We'll tackle that too. It's incredibly simple. So let's look at the AND rule right now. What the AND rule does is eliminates the AND. And we're going to use E for eliminate. So let's get rid of that AND. What we're going to do is we're going to draw a line and we're going to choose either the P or the Q, whichever we think will help us continue our deduction successfully. Let's choose the P. Why not? So there's our P, and here's what we're going to do. We're going to put E for eliminate, and I'm going to put AND, because we got rid of the AND and we chose one of the two. That's the AND rule. Let's move on to a second and a very important rule, the basis of almost all human intelligence. Here we have if P, and if there's an if, there's a then Q. What we're going to do is we're going to use modus ponens. Now, we talked about modus ponens earlier. We're going to add P, and that will allow us to deduce, guess what? You got it. The arrow goes to Q. Q. Notice we got rid of the arrow. It's gone now. We just have what's left over. And we'll put an E and an arrow, and we'll explain it to the people who are reading the deduction. This is MP. Now, if you just wrote MP, I'd be absolutely happy with it. But it is an elimination rule because we eliminated a connective. Now, here's a very important rule, too. That's going to be really handy later. Oftentimes, we deal with what's called the inclusive OR. We also discussed the difference between exclusive and inclusive. Remember, inclusive ORs allow both P and Q to be true, but if only one of them is true, the OR is true. So let's go ahead and get rid of one of those. Now, the way this elimination rule works is we can either get rid of P or we can get rid of Q, but we'll need to have something before that lets us do that. Well, let's pick on Q today. We're going to put a not in front of Q. So if it only takes one, we can keep the OR true, but we can knock this one out of the list of possibilities, in this case Q. There we go. We know it's P or Q. We know, back to the example we used, we went to a movie or a restaurant. Oh, wait a minute, we didn't go to a restaurant. But if the OR is true, that means we went at least to a movie, which will leave us with, you got it, P. And that's going to be an elimination rule. We're eliminating the OR. There's our V for OR. And that's called disjunctive syllogism. Now, I know that's a very strange term. It just means getting rid of one of the ORs. Disjunct is this or that. Disjunct, like a crossroads. We get rid of one of the roads or the other of the roads when we take that turn. So we are doing a syllogism, which is a fancy way of saying thinking about stuff. And we result with, well, we have P or Q. We don't have Q, so we're left with P. And we've eliminated the OR. Now, I'm not going to talk about biconditionals today. Remember, biconditionals are just if-thens that go both directions It's if P then Q, and if Q then P. It's just a complicated connective. I wouldn't worry about it. But let's look at knots, because knots are, well, not unimportant. They're important. When I say not unimportant, I've already given you the rule you need. It's very simple. Now, if I can start with a knot, and let's pick on P today. What if I can show you that it's not true that P? Then I have an elimination rule for that. I can get rid of both those knots. So, draw the line, and what are we left with? P. These two cancel each other out. If it's not, this one's doing the work. Together, we're left simply with P. If P is false, and it's false that P is false, what must be true? Whatever P stands for, guys. You know, cats have whiskers, at least, unless you've been screwing around with a lighter or something. And so that's called knot elimination. And it's also known as double negation, where the D stands for double, and the negation, well, that just means getting rid of the knot. Negation is just not. That's all negation means, guys. Other fancy terms? And have a great day. We'll show you how to use these in complex deductions in the near future.